Lebanon, the city of Baalbek. Tourists photograph ancient Roman columns. Guides tell stories about Jupiter and Roman emperors. Everyone looks up at the beautiful columns. Nobody looks down. And that's a mistake, because beneath the Roman temple lies something the Romans didn't build. A foundation made of 3 stones, each one 19 meters long, 4 meters high, 3 meters wide, each weighing 800 tons. They are called the trilithon. They are built into the wall at 7 meters above the ground. Modern engineers cannot explain how this was done. They cannot replicate it. With any technology available today, 800 tons. Let's understand what that means. An average battle tank weighs 60 tons. One of these stones equals 13 tanks. A Boeing 747 weighs 180 tons, fully loaded. One stone equals 4.5 aircraft. The Statue of Liberty, just the copper shell, weighs 225 tons. One Baalbek stone equals 3.5 statues of liberty. The most powerful mobile crane on Earth today, the Liebherr LTM 11200-9.1, lifts a maximum of 1,200 tons, but only at minimum height, on a perfectly flat reinforced concrete surface, with outrigger legs extending 10 meters in every direction, with a precisely calculated counterweight system. At Baalbek, the stone sits 7 meters above the ground, on a mountainside, placed there 2,000 years ago, or possibly much longer. 400 meters from the temple, in the ancient quarry, lies another stone. It's called Hajar al-Hibla, the stone of the pregnant woman. Dimensions: 21.5 meters long, 4.8 meters wide, 4.2 meters tall, cut from bedrock as a single piece. Weight: 1,650 tons. It was partially moved from the quarry. The transportation tracks are still visible in the rock. Then it was abandoned, left exactly where it stopped, for reasons nobody knows. Next to it lies a second abandoned stone. 1,240 tons, also cut, also moved slightly, also abandoned. Think about what this means. Someone started moving a stone weighing 1,650 tons using only human hands and ancient tools, and they were succeeding until something stopped them. We don't know what. We don't know why. We just know they were doing the impossible and doing it successfully. Modern engineering teams have run the calculations. To move a single 800-ton stone using ancient technology you would need a minimum of 40,000 workers, all pulling simultaneously in perfect coordination, a perfectly flat road with 0 incline from start to finish. Wooden rollers at least 1 meter in diameter placed under the stone, replaced every 10 meters of movement because they shatter under the weight. At that rate, movement speed would be 5 to 10 meters per day. Now apply this to Baalbek. The terrain between quarry and temple is uneven mountain slope. The distance is 400 meters uphill. The stones don't just sit on a foundation. They're raised 7 meters into the air and fitted into a wall with such precision that a knife blade cannot pass between them. Every single variable is impossible, not difficult. Impossible. 3 main theories exist. All 3 have fatal problems. Theory 1, the Romans built it. Problem: Romans documented everything. They left detailed accounts of building the Colosseum, the Pantheon, their aqueducts. About the trilithon, complete silence. Not one Roman text mentions building it. More telling, Roman historian Pliny the Elder visited Baalbek and described the trilithon as the work of giants who lived before us. Even the Romans thought someone else built it. Theory 2. Slave labor with ropes and wooden levers. Problem: physics. A wooden beam long enough and strong enough to lever an 800-ton stone 7 meters into the air does not exist. Oak, the strongest ancient wood, would shatter long before the stone moved. Engineers have modeled this repeatedly. The wood fails every time. Theory 3. Sonic levitation. Some researchers propose ancient knowledge of sound frequencies that could reduce the effective weight of stone. Legends of this technology exist from Tibet and Egypt. Problem: no physical evidence. No modern experiment has reproduced anything close to this effect at scale. All three theories fail. The stones remain unexplained. But here's what nobody asks. Not how they moved the stones. Why? Why move a stone weighing 1,650 tons when 100 stones of 16 tons each would do the same job? The Romans knew this. The Colosseum uses thousands of manageable blocks. The Egyptians knew this. The pyramids use 2 to 3 ton blocks arranged with brilliant efficiency. Using stones of 800 to 1,650 tons is not better engineering. It's not faster. It's not more stable. It makes no rational sense unless the point wasn't the building, unless the point was the demonstration. A message carved in stone and left for anyone who came after. We could do this. We had technology that could move mountains, and we wanted you to know it. Baalbek is Lebanon. But the same impossibility appears on the other side of the world. In Peru, at 2,800 meters altitude, stands a fortress called Ollantaytambo. Stones weighing 50 to 70 tons were carried up a near vertical mountain slope. The quarry is 6 kilometers away, across a river, across a valley, up a mountain pass. The stones are there. The explanation is not. Peru, the sacred valley of the Incas, 2,800 meters above sea level. The fortress of Ollantaytambo clings to a mountainside so steep it looks impossible to climb, let alone build on. At the very top, on the highest terrace, stand 6 enormous monolithic stones. Each weighs 50 to 70 tons, fitted together with millimeter precision. No mortar, no gaps. They have stood for centuries without moving a single millimeter. The quarry where these stones came from is visible from the fortress. It's on the opposite mountain, 6 kilometers away. Across the valley, across the Urubamba River, 400 meters lower in altitude. Someone moved these stones from there to here, and nobody can explain how. Let's trace the exact path these stones traveled. First, cut from bedrock at the quarry on the opposite mountain. Second, transported down a near vertical slope, 400 meters of vertical descent on unstable, rocky terrain. Third, crossed the Urubamba River, a fast-moving mountain river that floods violently every rainy season. Fourth, transported up the opposite slope, 400 meters of vertical ascent at angles approaching 60 degrees. Fifth, lifted through 14 agricultural terraces, each 3 meters high, each requiring the stone to be raised over the terrace wall. Sixth, precisely positioned and fitted at the summit. Total horizontal distance, 6 kilometers. Total vertical climb on the final slope, 400 meters. Stone weight, 50 to 70 tons each. Modern engineers who have studied this route say it is physically impossible, even with trucks and cranes. The slopes are too steep. The river crossing eliminates any conventional transport method. The precision of final placement defies explanation. But the transport is only half the mystery. These stones are not rough-cut blocks. They are precision machined on every face. The surfaces are so flat and smooth that modern stonemasons cannot replicate them without power tools. The edges meet at perfect angles. The stones interlock so tightly that a razor blade cannot fit between them. This is called polygonal masonry, and it appears all over Peru, but only at the oldest and most mysterious sites. Later, Inca construction used simple rectangular blocks. The polygonal precision belongs to something earlier, something unknown. Dr. Jean-Pierre Protzen, an architectural professor from UC Berkeley, spent years attempting to replicate Inca stonework using only period-accurate tools. His conclusion was direct. I was able to rough shape the stones, but I could not achieve the precision of fit. The ancient builders knew something we do not. The official story, the Inca Empire built Ollantaytambo in the 1400s AD. The problem, the Incas themselves said they didn't build it. When Spanish conquistadors asked the Incas about the megalithic structures, the Incas consistently said the same thing. They were built by the Viracochas, a race of giants. People who came before the Incas, people with powers the Incas did not have. There is another problem. The fortress is unfinished. Stones are abandoned on the transport route. Some are partially shaped in the quarry and left there. Some made it partway up the mountain and were left on the slope. Construction stopped, suddenly, mid-project, as if the builders simply vanished. Carbon dating of organic material found within the construction layers suggests some sections are far older than 1400 AD, possibly 2,000 years old, possibly 3,000. In the 1980s, a team of engineers and archaeologists decided to test ancient transport methods. Their goal, move a single 20-ton stone using only ropes, wooden rollers, and human labor. Conditions: flat ground, no river crossing, no mountain slope. Results: it took 3 weeks to move the stone 100 meters. Wooden rollers shattered constantly and needed continuous replacement. Multiple workers were injured. The stone repeatedly became unstable and nearly crushed people. 20 tons, flat ground, 100 meters, 3 weeks. At Ollantaytambo, 50 to 70-ton stones. Up a mountain, across a river, 6 kilometers, dozens of stones, all placed with millimeter precision at the summit. The mathematics does not work. The physics does not work. The logistics do not work, and yet the stones are there. Ollantaytambo raises questions that have no answers. But 50 kilometers away stands something that goes even further beyond explanation. A fortress called Sacsayhuamán. The stones there weigh up to 200 tons, and they are fitted together in a 3-dimensional interlocking puzzle so complex that modern laser scanning cannot fully map the geometry. Engineers call it the most sophisticated stonework on Earth. Nobody knows who built it. Nobody knows how. Cusco, Peru, 3,400 meters above sea level. On the hill overlooking the ancient Inca capital stands Sacsayhuamán, a fortress, or a temple, or something else entirely. Nobody agrees on what it was built for. What everyone agrees on, it should not exist. The largest stone in its walls weighs 200 tons. It has 12 distinct faces, 12 different angles, and it fits perfectly with every stone surrounding it, like a piece of a 3-dimensional puzzle where every piece is the size of a house. No mortar, no gaps, no cracks, multiple major earthquakes, centuries of neglect. The stones have not moved. Spanish conquistadors saw it and believed it was built by demons. Modern engineers look at it and reach similar conclusions. Let's understand what precision means at Sacsayhuamán. These are not rectangular blocks. Each stone has a completely unique shape. Some have 3 faces, some have 12. Some have more than 20 distinct surfaces, each one meeting its neighbor at a different angle, a different plane, a different geometry. And every single surface mates perfectly with the stones around it. Modern laser scanning has been used to map the joints at Sacsayhuamán. The tolerances measured are in fractions of a millimeter, equivalent to modern CNC machine tooling. This is not rough ancient construction, this is precision manufacturing. But the stone used is andesite, one of the hardest stones on Earth. And the tools available, according to official archaeology, were bronze chisels and stone hammers. Bronze is softer than andesite. You cannot machine andesite with bronze any more than you can cut steel with aluminum. Dr. Jean-Pierre Protzen of UC Berkeley spent decades studying Inca stonework. He conducted controlled experiments attempting to fit stones together, using only tools.
Audio is
the
characterized
Incas
by the
supposedly
sounds of
had.
a workshop environment.
His process for fitting two
male voice
stones
is heard
together.
Okay, easy now.
Step
Lower it
1.
slowly. Watch the edge.
Roughly shaped stone A.
Almost there. Just a bit more
Step
to the
2.
left.
Lift stone B, the neighboring block, and press it against stone A. Step 3. Mark all contact points with chalk. Step 4. Lower stone B. Step 5. Refine stone A at the marked points. Step 6. Repeat. To achieve an acceptable fit on just one face of one stone took him 3 weeks of continuous work. At Sacsayhuamán, some stones have 12 faces. Each face mates with a different neighboring stone, and the stones weigh not kilograms, but dozens or hundreds of tons each. To fit a 12-faced, 100-ton stone using this method would require lifting it hundreds of times. The process would take years, per stone. The fortress contains thousands of stones. The math makes
the construction of Sacsayhuamán
the stones
required
exist
an
anyway.
unprecedented
Some researchers
mobilization
have
of labor.
proposed a radical alternative. The stones weren't carved to fit. They were softened. Local Andean legends, recorded by Spanish chroniclers in the 1500s, describe a plant whose juice could temporarily make stone as malleable as clay. The plant supposedly grew in the jungle east of the Andes. Birds were observed using it to carve nesting holes in rock faces. Spanish explorer Pedro Chiesa de Leon wrote in 1553 about witnessing Andean people using a liquid to work stone in ways that seemed impossible.
Completely absent
Modern
of
chemistry
tooling.
says this
The ink
is
on the right,
impossible.
however.
Stone
We have
is
ledgers,
crystalline.
census counts,
Its molecular
but no
structure
mention of the
cannot be
construction of
temporarily
Sacsayhuamán.
altered by organic
It's as if
compounds,
the records vanished.
according to current understanding. But look carefully at some Sacsayhuamán stones. Some show surfaces that appear molded
Notice
rather
the
than
stark
carved.
contrast.
Rounded
the megalithic
edges,
stones on the left
flowing
bear no
transitions
tool
between
marks,
faces,
while the confirmed
shapes
Inca
that would be
masonry on
impossible to achieve by cutting. Some blocks appear to have been pressed together while one was still soft, with material squeezed into gaps
But how
like
is this
putty.
possible?
And some
level of
stones appear
erosion
to have
here
fingerprint
suggests
scale
centuries of
impressions
heavy
pressed into their
rainfall.
surface, as if the stone was once soft enough to touch. Official
During the
history.
last ice age,
Sacsayhuamán
massive melt
was built by the Inca Emperor Pachacuti, beginning around 1438 AD. 20,000 workers, 60 years of construction. The problems with this story are severe. First, the Incas left no records of building Sacsayhuamán, a civilization that carefully documented its history. Census records, agricultural records, astronomical records left nothing about constructing their greatest structure. Second, Spanish chronicler Garcilaso de la Vega, who grew up in Cusco and spoke Quechua as his first language, wrote
trying to find a gap, but it's impossible.
that the Incas
And they
did
did
not
this
know how the
centuries ago.
fortress was built.
It's mind-boggling.
Third, the megalithic stonework style is completely different from confirmed Inca construction. Proven Inca walls use regular rectangular blocks with clear chisel marks. The Sacsayhuamán megalithic stones show no tool marks whatsoever on their finished faces. Fourth, geological examination of some stones reveals erosion patterns consistent with exposure to flowing water. Sacsayhuamán sits on a mountaintop at 3,600 meters altitude. There is no water source that could produce this erosion, unless the site is far older than assumed. Old enough to have experienced conditions that no longer exist, Sacsayhuamán defies engineering explanation. But in Bolivia, 4 hours away, lies a site that doesn't just defy explanation. It defies the entire timeline of human civilization. Puma Punku, stones machined to tolerances of 0.02 of a millimeter, perfect right angles, interlocking components that look like industrial parts, and an age that, if accurate, means someone was doing precision stone manufacturing before agriculture existed, before writing, before the wheel. Bolivia, the Altiplano Plateau, 3,800 meters above sea level. In the thin, cold air near Lake Titicaca lies Puma Punku, the door of the Puma. At first glance, it looks like a field of ruins, scattered blocks, destroyed structures, random chaos. But walk closer, run your hand across the stone surfaces, and you realize immediately, these are not hand-carved rocks. They are manufactured components, machined parts, cut with a precision that modern engineers associate with industrial equipment, not ancient civilizations. And according to the most conservative dating, they are at least 1,500 years old. According to other evidence, much older. The blocks at Puma Punku are made of andesite and red sandstone. Andesite ranks 7 on the Mohs hardness scale. Steel ranks 4.5. You cannot cut andesite with steel tools, you can barely scratch it. And yet these blocks have perfectly flat surfaces, measured with modern laser instruments, flat to within 0.02 millimeters across entire faces. That is the tolerance of a precision ground machine part. Perfect 90-degree angles, accurate to within minutes of arc, not achievable by hand, perfectly straight grooves cut into the hardest stone, with sharp right-angle corners at the bottom of each groove. Try cutting a groove like that into concrete with hand tools. It cannot be done. Now do it in andesite. Twice as hard, perfectly circular drilled holes, some going completely through the stone, all parallel to each other, all identical in diameter. Modern stonemasons with power diamond tools confirm matching this precision in andesite requires CNC equipment or better. There is no manual method that produces these results. The most iconic elements of Puma Punku are called the H blocks. Viewed from above, they form the shape of the letter H. Each one is carved from a single piece of andesite. Each weighs 8 to 10 tons. The H blocks have perfectly flat surfaces on every face, precision grooves running along their length, small rectangular recesses cut into the surface at exact positions, identical dimensions repeated across multiple blocks, suggesting standardized production. The grooves in the H blocks are perfectly straight with sharp 90-degree corners at the bottom. This geometry is not achievable by hand in hard stone. Modern machinist tests confirm these grooves were cut by something moving in a perfectly controlled straight line with constant downward pressure. A machine, not a hand. Multiple H blocks are identical to each other. They were mass-produced to a standard, like factory components. Engineers who study Puma Punku consistently arrive at the same disturbing conclusion. The precision serves a functional purpose, not an aesthetic. In normal ancient architecture, precision serves beauty. Smooth columns, symmetrical facades, pleasing proportions. At Puma Punku, the precision is mechanical. The blocks have interlocking shapes, precisely dimensioned recesses, channels that align perfectly when blocks are assembled. They were designed to fit together in a specific way, like components of a machine or structure that required tight tolerances to function. Computer analysis of the block geometries reveals a modular
The simulation demonstrates
Certain
that while an
dimensions
earthquake
repeat
caused these blocks
exactly
topple,
across
seismic
different
forces
blocks.
alone cannot
Certain
explain the
angles
widespread
are
scattering.
standardized. The builders used a system of standardized measurement, thousands of years before standardized measurement was supposed to exist. Some blocks have what appear to be eye-shaped metal clamp recesses cut into their tops, designed to hold metal fasteners connecting adjacent blocks. When archaeologists excavated the site, they found traces of a metal alloy in these recesses. An alloy of copper, arsenic, and nickel. A composition not found naturally and not known from any documented ancient metallurgy in the region. Official archaeology dates Puma Punku to approximately 500 to 600 AD, built by the Tiwanaku civilization. The problems with this dating are significant. Problem 1, the Tiwanaku used simple stone and bronze tools, the same technology as the Incas. If the Incas could not replicate this precision, and they demonstrably could not, How did the Tiwanaku with inferior tools? Problem 2. Geological analysis of water erosion on certain stones suggests the site was submerged or exposed to significant water flow at some point. Lake Titicaca is nearby but lower. When was Pumapunku underwater? Not in the last 2,000 years. Problem 3. Astronomical alignments built into the site architecture match the sky configuration as seen from this location approximately 15,000 years ago, not 500 AD. Problem 4. Some of the largest blocks weigh 130 tons. The nearest quarry for this specific stone is 10 kilometers away across difficult terrain. No explanation exists for how blocks of this weight were transported without roads or wheeled vehicles. What's almost as mysterious as how Pumapunku was built is what happened to it. The site looks like it was hit by a catastrophic event of enormous violence. 100-ton blocks are scattered like
Look at how
toys.
smooth this is.
Some are thrown dozens of meters
I've never
from
seen
their
anything
original
like it.
positions. Some are tilted at extreme angles. Some show fracture patterns consistent with massive impact force, not gradual decay. What force throws a 100-ton stone block dozens of meters? Not an earthquake. Seismic activity can topple structures but cannot throw massive blocks horizontally across open ground. Not flooding. Water can move objects but not against gravity and not with this violence. Some blocks show vitrification on their surfaces, a glassy fused layer that forms when stone is subjected to temperatures above 1100 degrees Celsius. This does not happen in ordinary fires. It requires industrial heat, a furnace, a volcanic event, or something else
massive
entirely.
Pumapunku block
The destruction of
weighs in at an
Pumapunku
astonishing
looks less
130
like the
tons.
slow decay of an abandoned site and more like the aftermath of a weapon being used against it. Pumapunku presents precision that has no business existing in the ancient world. But everything we've seen so far, Baalbek, Ollantaytambo, Sacsayhuamán, Pumapunku, is on dry land, visible, accessible. What if the most important evidence is underwater? Off the coast of Japan, 25 meters below the surface of the Pacific Ocean, lies a massive stone structure that has been submerged for at least 10,000 years. It has terraces, steps, right angles, straight edges, carved symbols, and it is either the most extraordinary natural rock formation on Earth, or proof that an advanced civilization existed before the last ice age ended, before any